Hello, good afternoon. We are Group 30, and today we are presenting Here For You. Where you don't see, we cover. Our team members are Manish, Andy, and myself, Varun Raguraman. I'll be presenting the first half of this presentation, while Manish will take the second half. So, what is our motivation? Why are we doing this? So, current hearing aids are fairly expensive. They tend to cost between $1,000 to $6,000 for decent ones at least. There's a lack of functionality. Generally speaking, the most common types of hearing aids simply act as boosters for sound. They will act as an extra microphone that is essentially attached to your ear. This may not help people discern specific noises or particular types of sounds. Additionally, there's a huge difference between the cheapest hearing aids and the most premium. For you see, while the cheapest ones will act as microphones, the most expensive ones will selectively filter audio depending on their inputs. Our goal is to prototype a cheap quality of life change to improve current hearing aids that will not replace them, but help substitute for some of the features that can only be found in more expensive models of hearing aids. So the organization of our product slash project are as follows. First, why do we do this? Second, what is our product? Third, who is it for? Fourth, our timeline. And fifth, our future plans. So to start off with some statistics. According to the World Health Organization, about 5% of the population have disabling hearing loss, and about 7% of them are children. Additionally, there's a fair portion of people who are over 65 years old or over 75 years old, seniors, who have hearing issues as well. Noisy subways, airports, even headphones to some extent, can all cause permanent hearing damage. So there's definitely a need for these sorts of projects, even in the future. Who specifically is our product for? Well, we wanted to prototype something that would not only suffice for very young children, but also for people at the other end of the spectrum, senior citizens. We wanted to provide a service that would be missing from current hearing aids for those particular reasons. So, what is our solution? Our proposal is something that will listen to noises and determine particular noises of interest. Taking them, it will then alert people to the fact that these noises have been mentioned. The reason why this is used is, first off, cheapness, because it is a fairly cheap, cost affordable sort of method to help solve for a particular existing problem. Secondly, because, as we said, it's only the most powerful slash expensive hearing aids that can generally use digital techniques to help isolate and modify the type of sound that people hear. So something that can do that on a cheaper, more affordable level, and can also do that fairly simply, is very much of value. And because our particular product simply notifies people by tapping them or by buzzing, it can be used by almost every single person, from a child to an old person. It doesn't matter the level of actual damage in that person's ear, because the device will simply listen for a particular sound and notify them that said sound has occurred. So the general design constraints that we operate under were as follows. First, we needed something portable. Second, self-contained. And third, we wanted something cost efficient. To that end, for portability, we decided upon a Raspberry Pi and armband approach. A Raspberry Pi mounted an armband that a person would wear and would be programmed to listen for and track certain sounds. We wanted it to be self-contained, so our software setup would have to be something that would be capable of picking up and alerting people to sounds without access to the internet. And finally, we needed something cost efficient. Again, so we chose something akin to a Raspberry Pi. We used a USB mic because that would be the cheapest sort of mic that we could implement into the system that would still work at a decent level. And finally, just a simple armband for the actual device's portions. So, to go into more detail on our actual software, I will turn everything over to Manish.
So for our internal structure of our device, we have the training data we used for the sounds. So in our demo right now, that's just me saying our group members' names. So that's what we've trained it to respond to as of now. SoPair is the audio processing software that we're using. Our filter is our software filter to get rid of background noise. And then our voice recording model is the external hardware that recognizes individual speakers. So our block diagrams are here. You'll see the simpler diagram starts with interest A is the noise of interest. It gets picked up by the mic. It goes into the Raspberry Pi. The Raspberry Pi sends a signal to the buzzer if it recognizes the noise. And then interest B is the user. They'll feel the buzz when the buzzer buzzes. So within the Pi, we have it set up so that it goes from the mic to our audio filter. It splits up into SoPair, which is listening for names, and then the voice recognition module is listening for who's the person speaking. Yeah. So our original timeline looked something like this. Gave some time to order hardware, set up software, build a device. Great. But given recent events, we had a change of plans, and we got through setting up about half the software, but a lot of our orders got delayed. So we ended up with a Raspberry Pi, a microphone. We could install SoPair on it, but we didn't get our voice recognition model in time, and we didn't get a, well, when we had to switch from using the lab at Rutgers to my house, we didn't have access to soldering equipment, so we couldn't even hook up the buzzer. But this is, I guess, what we got working. So there's the Pi. In this video, I'm saying Andy's name. It gets picked up. You'll see the empty blanks means I said something that wasn't one of the recognized names, but it still picked up a sound. So that's what it's letting you know. And it picked up my name and Varun's name. So yeah, the goal was after it picks up the names, it sends the signals to the buzzer. So in future plans, if we were to continue working on this project, we would train it to recognize other sounds like car alarms and stuff. We'd make the device smaller to increase the portability. We were considering maybe adding online compatibility. So we want the device to still work offline, but if we could get it to work better while you're connected online, that might be something to look into. We were looking into vibration patterning with the buzzer, so depending on what kind of noise it picked up, the buzzing would be different. So like someone said your name, it could be one long buzz. If it recognizes like that your mom is talking, it could be buzzing quicker, like 3 quick ones or something like that. The portable battery is part of making it more portable, I suppose. And also something we would have liked to improve on would be making the device more robust in crowded environments, so that I guess filters out background noise better. Yeah. So thanks for your time, everyone. I hope you're all staying healthy.